Welcome to the Metabolic Link, a podcast that explores the common thread of metabolism in health and disease. This is where science meets society. Welcome to the Metabolic Link. I'm your host, Dr. Dominic D'Agostino, physiologist, neuroscientist, and metabolic researcher. Today, we are sharing an exciting debate that I had the opportunity to moderate on a controversial topic that impacts millions of people worldwide. We're digging into the topic of sugar with two of the world's leading experts in this field, Dr. Richard Johnson and Dr. Layne Norton. Dr. Johnson is a professor of medicine at the University of Colorado. He's a clinician, he's an educator, he's a researcher with over 20 years of expertise in the role of sugar, with a particular focus on fructose and how that impacts obesity and diabetes. His groundbreaking research has been widely published and has been supported by the National Institutes of Health. Dr. Layne Norton is the founder of BioLayne and holds a PhD in nutritional sciences and is known for his science-based coaching and expertise in protein metabolism and in fat loss. He's also a successful natural bodybuilder and a drug-free powerlifter, as well as a globally recognized educator on the topic of nutrition science. So they are going to tackle the complexities of sugar, of fructose, of high fructose corn syrup, discussing everything from the human randomized control trials to mechanistic data. So get ready for a debate that not only explores the harmful effects of sugar, but challenges what we think we know about it. So if you enjoy this discussion, please don't forget to subscribe, leave us a review. We've got some exciting guests in store for you on this podcast, and we want to hear directly from you. And we also want to say a thank you to our sponsors of this podcast that include Genova Connect, Fatty 15, and iRestore for supporting this episode. They make this content possible to share with you for ad-free exclusive episodes of the Metabolic Link and a huge library of other metabolic health content. Be sure to check out our platform. That's the Metabolic Initiative at membership.metabolicinitiative.com. Now, please enjoy our debate with Dr. Johnson and Dr. Norton. Welcome, everybody. Thank you for joining us on the Metabolic Link podcast. I'm excited to be hosting this debate today between Dr. Richard Johnson and Dr. Layne Norton. So as you heard, they have a pretty extensive bio and expertise in metabolism, and Dr. Johnson specifically on fructose metabolism. The biggest question really impacting the overall health in the US today is a big topic actually in our medical education research is what is the cause of obesity? So we have 100 million people in the United States that have obesity, and it's slightly over 40% of the population. So there's generally not a good consensus as to why this is happening, or I guess a debate even in the literature. But the general consensus or hypothesis is that it's an energy balance problem. For example, calories in, calories out, that's the dominant view. And Dr. Layne Norton sort of holds that view, as do many other, experts in the field. There's an emerging, if you will, competing hypothesis of the carbohydrate insulin model of obesity. In particular, this idea that sugar has a special causative role in obesity. Many feel that this is an independent, the sugar-induced obesity and insulin is independent of calories. So there's really like two different carbohydrate theories. One focused on glucose component and its ability to stimulate insulin, which increases fat stores. So that's sort of debated quite a lot in different camps. And there's another sort of side by that, similar to that, is the focus on fructose specifically, the fructose component of the carbohydrates. And today, we're going to kind of talk about both, but really kind of focus on this idea of the fructose hypothesis and whether fructose has a causative role in obesity. And I think what we'll do just to start this off is that we'll have Dr. Richard Johnson kind of give us a framework for this particular hypothesis, and then we'll have Layne come in and talk about, some of the sort of give a rebuttal to that, and then we'll transition to a debate because there's a number of different arguments that we want to debate and go back and forth. So, Dr. Johnson, great to have you here. Great to have you both here. Excited to delve into this topic, which really there's so much confusion around this topic. So I'm glad you guys are here as experts in this topic to give us some clarity.
Thank you. So I'm Dr. Rick Johnson, and I'm a professor of medicine at the University of Colorado. I'm now emeritus. And I've been doing research in kidney disease and metabolism and sugar for decades. And I've written a couple books. Nature Wants Us to Be Fat is the most recent one. But we've done a lot of research funded by the National Institute of Health and other groups. And in my work, we stumbled upon fructose as potentially being extremely important in the obesity epidemic. Layne, it is a real delight for me to meet you, and I recognize you as an expert in nutrition as well, someone who's written books and it has a PhD in this, and I'm looking forward to this debate. And I'm going to, hopefully I will learn some things from you, but I will hopefully also pass some of my own knowledge to the audience as well. So I'm looking forward to this as a very constructive debate. It's a very important one, and it's one for which there are many world experts on both sides. So just as a background, obesity used to be a rare condition. If you go back to 1900, there were approximately 2% of the population were obese, and diabetes was present in 1 in 50,000 people. So we're talking about conditions that were really rare. And but since 1900, there was a gradual rise in obesity and diabetes, and then a dramatic kind of acceleration in the 1970s. And it's sort of now plateauing, actually, but it's been something that has become a major disaster in metabolic health. Now, when it was first showing up, between 1900 and 1920, researchers actually thought that it was linked with sugar intake, and they could show this when sugar was introduced into populations like Native American populations, the Pima Indian, and variety of different groups were exposed to sugar. It was followed about 10 years later by a marked rise in obesity and diabetes. And a guy named Haven Emerson, who was the New York City Health Commissioner, did a beautiful study in the 1920s where he linked obesity with sugar intake, and he actually looked at other countries like Australia, where the association wasn't there, where there was, I should say, there was no obesity, but there was no sugar exposure, or minimal sugar exposure. And so Emerson made the proposal that sugar might be playing a role in the cause of obesity and diabetes. And even Frederick Banting, who discovered insulin, felt that was the cause. But then in the late 1920s, Elliot Jocelyn presented the hypothesis that perhaps it wasn't sugar at all. It was overnutrition, a word he coined, in which he suggests that actually what's happening are people just eating too much. The food is tasty, it's more available, it's in the grocery stores 24/7. And so it's easier to get a lot of food. We're not controlling our intake, and we're exercising less, and too much in and too little expenditure leads to obesity. And this became the standard hypothesis that is still held today by many people. When the low carb diets were presented by Atkins and others, and the keto diets, there was this report of really phenomenal weight loss associated with carb restriction and with keto diets. And this launched a whole group of investigators, as well as became very popular among general people who are interested in losing weight. And so this kind of thrust the attention to carbs. And one of the thoughts was that, well, carbs contain glucose, glucose stimulates insulin, insulin stores fat. Maybe there's a specific type of food that could be causing obesity. And this led to the carb insulin model, suggesting that maybe we're just eating too many carbs, and especially high glycemic carbs and carbs that raise the blood glucose in your after you eat them, things like potatoes, rice, crackers, and this kind of thing. So so that kind of changed the viewpoint, and there became this big group called the carb insulin model, and Gary Taubes and others have kind of championed that model. And then there was the calorie in, calorie out model. These were the two major models. Now, yours truly got involved around 2000. When I started, I was studying uric acid, which is a substance that can cause the disease gout and strongly associated with obesity. And it turns out that sugar can raise uric acid. So I was studying sugar. And actually sugar, we should just kind of comment, sugar contains a molecule called glucose and a molecule called fructose. And these two molecules are bound together to make up sucrose or table sugar. And then high fructose corn syrup is also a mixture of glucose and fructose, but where they're just mixed together, and usually with a little bit more dominance of the fructose because it's a little sweeter. And these two sugars are called added sugars. So high fructose corn syrup and table sugar are called added sugars. And they make up about 15% of the current diet. And so there's a large exposure to these sugars, and along with the other carbs. And so what happened is, the carb insulin, people were saying, hey, in the sugar is the glucose. The glucose stimulates insulin. The fructose is there, but it doesn't stimulate insulin, so it's probably not so important. But anyway, fructose is the sugar that raises uric acid. And when we were studying, we were giving sugar to animals and lowering the uric acid, and we found that we could block some of the effects of sugar by lowering uric acid. And that kind of triggered me to thinking, what is it about fructose, which raises uric acid, that is so special that it seems that just by lowering uric acid, I could have a benefit. So this launched me into the world of fructose and hundreds of studies actually, and I've come to the conclusion that it's actually extremely important. And basically, I'm going to tell you a little bit about the fructose survival hypothesis. So basically, animals, many animals will purposefully become obese at certain times of the year. We know this, like bears, for example, will maintain their weight pretty normally through the summer, but as fall comes and winter's coming, then they know that there's not going to be food around. They start to increase their food intake, and they become fat, so that when they hibernate, they will not eat or drink. They'll be in their dens, but they will burn the fat that they've stored to survive the winter. And when they burn the fat, they produce calories from the fat that they use. It's called ATP, is this energy they produce from the fat. And that energy helps them survive the winter. And they also, when they degrade the fat, it produces water, actually. When fat doesn't contain water, but when you break it down, it makes water. So they get energy and water from breaking down the fat. So they don't have to drink, they don't have to eat, and they can survive the winter. When we looked at these animals, we realized that they weren't just storing fat. They actually went through a whole process where they changed their behavior. They began to forage for food, searching for food. They were hungry, and they ate a lot more than they normally did. They could not control their appetite, and so they kept eating, and they developed fatty liver, and fat went up in their blood, and they became insulin resistant. And actually, they developed what we call the metabolic syndrome, which we've been thinking of as a disease condition that can predispose to obesity and hypertension and diabetes and so forth. But actually, it's a purposeful move that these animals do this. So we became very interested in what triggered that change, because they were normally controlling their weight, and then suddenly they would gain a lot of weight. And when we studied this a little bit, we found that that they were eating a lot of fruit in the fall. And normally we think of fruit as healthy, and fruit has a lot of great things. But as the fruit ripens, the sugar content goes up, and the good things like vitamin C and so forth tend to go down. And so what happens is, when you eat a lot of it, it's sort of like getting a fair amount of fructose. And so what we did is we thought, could the fructose be involved in changing the regulation of weight, where suddenly you become more hungry? And we gave fructose to animals, and we could recreate this finding, especially if we put the fructose in a liquid form. They particularly would develop metabolic syndrome very quickly. And they got insulin resistance, and more so, they changed their regulation of weight. Instead of controlling their weight, they kept eating it. When we studied it, we discovered that they were becoming resistant to a hormone called leptin. And leptin is a hormone produced by fat cells that kind of tells us when to stop eating. But people who are overweight were discovered to be resistant to leptin. And when we gave fructose, we could induce that leptin resistance. And so we could recreate this syndrome where they continued to eat. We went on, did many, many studies, and basically we came to the conclusion that fructose is actually a sugar that's aimed at trying to tell the animal, it's a survival mechanism. When you eat it, it tells the animal that you need to store fat for a crisis to come. And so what happens is, when you feed an animal fructose, they start storing fat. They lose their control of appetite and so forth. And then when finally the winter comes and the food goes away, they hibernate and burn off the fat. The biggest breakthrough and relevant to this discussion today is that we discovered that fructose is not just coming from the sugar we eat. So the main source in the diet is table sugar, honey, fruits contain fructose, but actually the body can make fructose from carbs. And in animal studies, we could show that that was quite significant, and that even high glycemic carbs like bread and crackers and potatoes and rice, these are foods that when you eat them, when the blood glucose goes up, it stimulates insulin, but it also stimulates the conversion of glucose to fructose. And we found that it could be accelerated by salt, because salt triggered the enzyme that converts the glucose to fructose. And so salty foods are particularly worse. And the story goes on and on, but the biggest thing to recognize is that when we say that fructose is driving obesity, we're not limiting it to just the sugar we're eating, but also to the fructose that's being made in our bodies. So I'll stop there. That
was a
over.
very compelling starting point
Thank you.
to go from. And I think maybe a lot of people didn't know, some of the things. Well, maybe we'll come to it, but you mentioned that the trigger for metabolic syndrome and sort of obesity in the animals was the consumption of fructose. And I guess we'll be talking about, did they also consume more calories in the process of doing that?
Yes.
Okay.
When you eat the fructose, after a couple of weeks, you start to eat more calories. So the fructose induces
trigger.
leptin. It is the trigger that stimulates the leptin resistance that then drives the food intake.
Okay. This episode of the Metabolic Link is brought to you by Genova Connect. Knowing your essential and metabolic fatty acid levels are key to maintaining your body's overall health. Achieving the right balance of fatty acids to help reduce inflammation, support heart health, and improve mitochondrial function are really key for overall health and longevity. Genova's Metabolomics Plus and comprehensive fatty acid tests provide a detailed report including the levels of omega-3 fatty acids, omega-6s, and also C15 to help identify potential imbalances. Higher levels of these fatty acids are associated with an increase in life expectancy of up to 4 or 5 years. So fatty acids are evidence-based longevity biomarker, and I think they'll eventually become sort of part of our standard blood work. Genova also offers a focused single marker biomarker test for C15. This is an essential fatty acid linked to healthy aging. So take control of your health by visiting gdx.net/metabolic link to learn more and use the code metabolic link for 15% off any of their test kits. Now back to our episode. So now we're going to pivot to Layne's perspective, maybe on sort of the topics that were just discussed here in that framework and hypothesis, which is pretty compelling, but maybe put things into perspective from the perspective of human nutrition.
Yeah, thanks, Dom. And thanks, Rick, for agreeing to do this discussion. Regardless of differences of opinion, I very much appreciate when somebody's willing to reach across the aisle, so to speak, and have this sort of discussion because I think it's going to be productive. So I think first I'm going to give a really short background about myself and why I think that's relevant. So I actually did a BS in biochemistry. I'm a biochemist as an undergrad and did a PhD in nutritional sciences as a graduate student. And I actually am very grateful for that because I think as a biochemist, I found myself being looking at the blades of grass rather than zooming out and looking at the forest, right? And so I think it's important to have both. I think that's really important. And I think it can get down to a discussion of kind of mechanisms versus outcomes. And, you know, when it comes to mechanisms, I'm not going to dispute anything that Rick said. All those are viable mechanisms and they all exist. Those are all viable biochemical pathways. I think what we have to keep in mind is that outcomes in humans are the summation of dozens, hundreds, sometimes thousands of biochemical pathways kind of summing up to an outcome. And I'll just give a really brief example of that. So, for example, we know that aspirin is an anticoagulant. The overall effect is it reduces coagulation, but it also activates some procoagulant pathways. And so if we just zoom in on that blade of grass, we could tell people with a heart condition, don't take aspirin. It activates this pathway. So I just want to use that to kind of set up where I'm going to go with this.
Sure.
And I think when it comes to hypothesis, you know, a lot of different hypotheses can be viable. And I'm actually going to argue that energy balance is the unifying hypothesis between these things. And the reason I fall on energy balance is not because it's the most popular, because when I was a graduate student, I actually held a similar belief as Dr. Johnson, which is I thought that fructose and sucrose were uniquely fattening. I thought that that was the case. And I want to say right now, I do think fructose in the form of high fructose corn syrup, sucrose, highly refined carbohydrates, hyperpalatable foods is causative for obesity. I do think that. Where I differ is I don't think it's independently causative outside of the energy it contains. So that is my view. And what I will say is I think for a hypothesis to be very robust is one, it has to, of course, be replicated in a bunch of different labs across different countries. That's a given. But I think the other thing is it has to survive not super constrained controls. And one of my big problems with the carb insulin model is every time a study comes out that gets refuted, all of a sudden the carb insulin model moves a little bit in terms of what it actually is. And so I'm actually not, my understanding of the carb insulin model, for example, was, okay, you consume refined carbohydrates, that stimulates insulin. Insulin drives fats into adipose and glucose. Now they are inaccessible for the rest of your body. And so your body senses that you are starving and you overeat response. So essentially, and again, my understanding of the carb insulin model, the crux is not that excess calories cause obesity. It is that refined carbohydrates increase insulin, which stimulates people to eat because they feel like they're starving or there's a lack of energy available to the rest of the body, and they overeat in response. So essentially, they're flipping the cart and the horse, right? And so, most of the arguments about this are very mechanistic in nature. It's very much looking at individual enzymes and how they affect things. And so if I zoom out, the first thing I'm going to ask when we're testing a hypothesis is, if we directly measure the outcome, what do we see? Do we have human randomized control trials that actually directly look at this? And the answer in the case of the carbohydrate insulin model is absolutely unequivocally yes. So we have over, at least as of 2018, there were over 20 human randomized control trials where they equated calories and protein, which is very important because a lot of the early low carb work was with a little bit higher protein. And so we know protein is thermogenic and can have an effect on satiety. So it's important to equate protein between these diets. So 20 studies where they equated protein and calories, and either it was in a metabolic ward or they provided food to participants, which drastically increases adherence, which is important because sometimes in free living studies, especially as they go on, adherence wanes. And this is why people that are kind of like towards the health at any size, like extremist, they will say, well, no diets work because, you just regain all the body weight because that stuff doesn't work. And it's like, no, they work until people just stop doing them. So if we look at the diets where we can be where we have a high degree of certainty about adherence, the summation of those studies showed that by protein calories equated, varying carbohydrates and fats, essentially no difference in the loss of body fat. In fact, the meta-analysis actually showed a slight favoritism towards low-fat diets of about 16 grams of extra fat loss per day. Now, I don't think that's clinically relevant, and I wouldn't really care about that, and I'm not even sure it's a real effect. But the point being, it's like, okay, well, that's a pretty major strike, right? Because if it was insulin and carbs, we would really expect to see a difference here. And then if we look at the most tightly controlled studies in metabolic wards, they all come out the same, which is there's no difference, even between low carb, low fat, even showing big differences in insulin levels. And I think, again, mechanistically, when you think about insulin, it makes sense. Okay, insulin inhibits lipolysis, it drives fat into fat cells. But I think people forget that fat oxidation is not the same thing as the actual loss of body fat. So let's take two different diets: high carb, low fat, low carb, high fat. Low carb, high fat, you burn a lot of fat because insulin is low, for sure. High carb, low fat, you don't burn much fat because insulin is higher. Okay, that's a given. But fat loss is not just fat oxidation. It is the balance between the amount of fat you store versus the amount of fat you burn. Both processes are always simultaneously occurring. It's the relative rates of each that change. And so if you're burning more than you're storing, you're losing fat. If you're storing more than you're burning, you're gaining fat, and so on and so forth. And so if we look at metabolic tracer studies, what we see is that less than 2% of the carbons that wind up in adipose tissue originate as dietary carbohydrate, because dietary carbohydrate is preferentially oxidized. That's one of the functions of insulin. You oxidize carbohydrate you take in, your body's kind of got to burn it. So what's happening is, on a high fat, low carb diet, you are burning a lot of fat, but you're also storing a lot of fat because over 98% of the fat you store in adipose originates from fat you consume. Now, if you're on a low-fat, high-carb diet, you're not burning much fat, but you're also not storing much fat. And so what actually unifies these two things is energy balance. Are you consuming more energy than you're expending? Now, I think another major kind of blow to the carb insulin model is they have given, it's like one of the kind of cruxes is, well, if you're inhibiting free fatty acid release out of adipose tissue, you won't be able to lose fat. And there was actually a trial where they gave something that inhibits free fatty acid release from adipose tissue. And they actually saw that these people lost similar amounts of weight as people who weren't taking it. And I think I think the biggest blow, quite frankly, is the current weight loss drugs like Ozempic, the GLP-1 mimetics, because again, it is focusing on an acute response. And I know Gary Taubes has said, well, these GLP-1s, they drop insulin over time. Yes, because people lose weight and lose body fat. And when you reduce body fat, insulin drops. We know this very, very clearly. Because as you lose body fat, you become more sensitive to insulin, become more sensitive to leptin. Now, what do GLP-1s do? Well, they cause a massive reduction in energy intake. They also stimulate an increased insulin response to meals, at least initially. So if this hypothesis, for this hypothesis to be true, GLP-1s can't exist. Like, it's just incongruent with the hypothesis. Because if you're giving something that's going to acutely raise insulin, that should stimulate appetite. That should increase energy intake, and we see the exact opposite. So that's kind of my quick on the carb insulin model. As far as, and I know we're going to get more into the fructose things, I think, again, if we look at the human randomized control trials, we have several meta-analyses now. If you're adding fructose to the diet in the form of, let me put this way, in the form of hyperpalatable sources of fructose, high fructose corn syrup, sucrose. And the reason I say that is because there are recent studies where one study in particular, where they gave people 150 grams of fructose per day and actually saw a slight drop in energy intake, because pure fructose is not hyperpalatable like sucrose or high fructose corn syrup is, or sucrose and high fructose corn syrup as part of an overall like food matrix, right? Because if it was just sugar that made something hyperpalatable, we would expect to see people just mowing down sucrose, right? It's a cheap source of sugar. But when people talk about like high carb, high sugary foods, a lot of times they're talking about cookies, cakes, those, baked goods, ultra processed, that aren't just high in sugar. They're high in fat. They're high in sodium. They have a certain texture to them. They have a certain mouthfeel. When it comes to hyperpalatability, it really depends on the overall food matrix. Because if I just mix sugar and oil and salt together, I mean, it'll stimulate your taste buds, but you're probably not like mowing that down. You know what I mean? I'm probably not walking around with a water bottle with oil and sugar and salt in it, right? Sipping on it. I mean, might be good for, a race or something like that, but I don't think much else. So I think there's a broader conversation there. And what I will say about the energy balance model is that it holds up across time, across labs, across rigorous or loose testing standards. And really, if we look at fructose, so when fructose is added to the diet as part of hyperpalatable foods, yes, people do tend to gain weight because they overconsume calories, because they consume more calories. And so in that aspect, I do think fructose is problematic as part of these hyperpalatable foods. But I think the overall food matrix is the problem, that people are consuming too much. And just a few more kind of quick hits, kind of going back to the carb insulin model. There was also a paper published in 1975 where they published an average weight loss, I think, of 65 kilograms, which for my freedom-loving US friends is about 145 pounds average weight loss. And now it was an 1,100 calorie diet, right? So very low calorie, but the majority of it was from white rice, white bread, and grape juice. So again, for the carb insulin model to be true, this really can't exist, right? Like that can't exist. That is a very insulinogenic diet. So again, mechanistically, okay, I can see for the carb insulin model, I can see how people got there. But when we hold it up to the flame of rigorous testing, it just doesn't hold up. And typically, when people try to explain like why it didn't hold up, there's kind of a lot of hand waving arguments, and they say, well, they just didn't do this thing right. And what my response to that is, if your hypothesis requires such tight constraints to be provable or supportable, it is not a very robust hypothesis. And then when it comes to fructose, the things I'm going to mention, and I am going to focus on the human studies because, again, where I started, because I went to graduate school, I thought that high fructose corn syrup, fructose, sucrose were uniquely fattening. And I actually was sitting at a grad school mixer, and I was listening
One more minute.
I was listening to a professor who did a study on high fructose feeding in rodents and saw an increase in like these genes that are associated with lipogenesis and obesity. And the other, I think it was another professor, was like, so we know high fructose corn syrup is obesogenic, it causes obesity. And the professor who did this research said, no, it's the calories. We were just trying to do a proof of concept. He goes, we over 63% of the diet, the calories were from fructose. He's like, even if you consumed pure high fructose corn syrup as all of your calories, you wouldn't get that high. And so in studies where they give physiological amounts of fructose and they exchange it 1-for-1 with other types of sugars, you don't see changes in body weight, or you see equal weight loss. And I'm also going to point out that in studies where they give a physiological amount of fructose or even high fructose, like 60 grams a day for up to a year, they don't see increases in the levels of uric acid. So again, I think the energy balance hypothesis is the one thing that actually ties this all together versus some of these other hypotheses. But I want to emphasize that I think these pathways are all valid.
Mm-hmm. Thanks, Layne. That was a great overview. So are you struggling with thinning hair or receding hairline? So you're not alone. About 50% of people my age and middle age have thinning hair, including me. As we age, you want to do things for early prevention. So that's really key, especially considering drug-free options to do this. So the iRestore Elite Helmet is an engineered way to combat hair loss for both men and also for women. So they use clinically proven low-level laser light therapy, so also called photobiomodulation. The iRestore Elite Helmet delivers red and near-infrared light directly to the scalp, and this stimulates dormant hair follicles, boosting circulation, extending the growth phase of the hair cycle. So there's about 300 powerful light sources that are at different wavelengths. So here's the helmet here. And for those that can see it, so with 300 powerful light sources, there's a 650 nanometer laser, a 660 nanometer LED, and also there's an 850 nanometer near LED. So I just do 12-minute sessions 3 to 5 times a week, and I'm convinced also that the red light is going directly to the head, improving circulation. I also feel like an enhancement of mood and attention span while I'm using it, usually while I'm doing work. So iRestore Elite is hands-free, it's safe, it's comfortable to wear, it's very portable, it has a carrying case so you could take it if you're traveling. iRestore is so confident in their products that they offer a 12-month money-back guarantee. So you can gift it for free, use it for 12 months, up to 12 months, and ship it back if you're not satisfied with the results. So I'm a big believer that food is medicine. We are here at the Metabolic Link, and I'm also a strong believer that light is medicine. So for limited time only, our listeners are getting a huge discount on the iRestore Elite when you use the code Metabolic Health at checkout. So go to iRestore.com and use the code Metabolic Health. So again, head over to iRestore.com and use the code Metabolic Health, all one word, at checkout for this exclusive discount offer. So this supports our show. So we really appreciate your support for our show, and then tell them that we sent you there. Now back to our episode. Maybe like the jugular question for Rick here. Rick, convince me that sugar and fructose causes obesity independent of excess calories in humans. What evidence exists for that specifically?
Yeah. So the way we're going to break this up is, first off, thank you, Layne, for your suggestion, your comments. And so let me just begin by saying that the fructose hypothesis is distinct from the carbohydrate insulin model. So we have to recognize that they're different pathways. What the fructose model suggests is that when you give an animal fructose, actually, like if you give an animal fructose in the drinking water, so for the first 2 weeks, they will reduce their calories from chow to make up for the calories in the drink. So they maintain energy balance and they don't gain weight. But then after several weeks, they become very hungry. They lose their control of appetite and they drink the sugar water, but they also eat more. And then they become fat. Over time, they become fat, insulin resistant, diabetic, et cetera. And so what we think is that the way fructose works is it works by stimulating you to eat more. And it induces this thing called leptin resistance. And we've actually done studies, and you can stop the sugar and they will stay leptin resistant for several weeks. So you can actually switch them to, like we did a diet with, it turns out that animals don't really gain a lot of weight with lard alone. But if you make them leptin resistant and then give them lard, they become more. The fat, they eat a lot more of the fat once they're leptin resistant. So it turns out that when you give fructose to an animal or sugar, it makes them eat more. Now, if you do a study, which is where you're getting at, where you clamp the food, like a controlled feeding trial, where you say, okay, I'm going to give these animals sugar and I'm going to give these animals some other kind of carbohydrate, but not containing fructose, and you match for protein and fat. If the calories are clamped, you are absolutely correct. There's going to be no change in weight despite eating a lot of sugar, because calories do drive weight gain. And so the calorie balance, everything you talk about is absolutely true. But the way it works is, though, in an ad libitum situation where you're not controlling how much they eat, the fructose-fed animals will eat more. And this was, it's shown in clinical trials as well. And so, like, Stephen Piper is this scientist. He's a very smart guy, funded by the sugar industry. But what he did is he said, okay, I'm going to look at clinical trials in humans with weight gain, and we're going to look at controlled feeding trials. So in one setting, if you're given fructose and we don't control if it's ad libitum, so they can eat more, we're going to look at those, and there they gained weight. But if we clamp them, did a controlled feeding trial where we don't allow them to eat more calories, the human studies are negative. But that is what I would expect, because the way fructose causes weight gain is by stimulating calorie intake. And the calorie balance hypothesis is correct when it comes to weight. But interestingly, Layne, you know this, if you exercise a lot, you can increase your muscle without necessarily increasing your body weight. And, a lot of people will work out and they can gain muscle without gaining weight. And what happens is they're changing their body composition, where they're increasing their muscle and they're reducing their body fat. So we know that this can happen, right? So when you give fructose in a controlled diet where the animals are having equal calories, their weight doesn't go up, but the body composition changes. They put fat in their blood, in their liver, visceral fat. They become hypertensive, insulin resistant. So there are two mechanisms. One is, the energy balance drives weight gain, but fructose does other things independently of energy excess. And in fact, we can even calorically restrict animals and create diabetes and obesity by giving them fructose-rich sugars. Now, so that's the first point I want to make. And then we try to figure out the mechanism, the chemical mechanism for this. And there's a chemistry mechanism, biological mechanism, but basically fructose is the only nutrient that lowers intracellular energy, ATP levels. And when it lowers the ATP levels, that seems to be associated with stimulation of hunger and all these pathways. Now, interestingly, I was always taught that if your energy ATP levels were low, that you eat food and you replace the ATP and the extra goes into fat. But our work shows that the way it actually works is the ATP levels are suppressed because there's a suppression of the mitochondria. And then what happens is you get calories, and instead of the calories going to ATP, they go to stored energy or stored ADP, which is fat. And that's how it works. Now, you talked about insulin, and I love the carb insulin people. I love the fact that the summary is that carbs are bad, and that's totally in alignment with our work because carbs can be converted to fructose. But the insulin stimulation to fat, I don't think holds up fully, just as you say. And what we did is we gave glucose, which is the carb that stimulates insulin. We gave that to mice in large doses, and they became fat. They became diabetic, insulin resistant, all those things consistent with the carb insulin theory. But we found that actually they were converting a lot of the glucose to fructose in their body. And when we gave glucose to animals that could not metabolize fructose, we could, even though insulin was being stimulated, we could really reduce the development of obesity, insulin resistance, fatty liver, et cetera. Some of the glucose was stimulating insulin and causing these things, but much of the glucose was actually being converted to fructose. And so we believe that that it's mainly the conversion of carbs to glucose gets converted to fructose, and then you get dietary fructose, and that's what's driving it. And when you go on a keto diet, and I think you're well aware of this, and in fact, it's one of your proposed methods, to reduce weight. When you go on a keto diet, you tend to lose, you lose this hunger. Basically, keto diets, you don't necessarily need to do caloric restriction. Most people who go on a keto diet know they don't need to restrict calories because just by nature, they're going to eat less. But if you go on a low-fat, high-carb diet, you almost always have to go on a caloric restriction in order to lose weight. The other final thing I want to talk about is that Layne, you're making a lot of points related to dieting, and you are 100% right. If you want to diet and lose weight, you have to restrict the number of calories you eat. So when you go on a diet, it doesn't really matter if it's a low carb, low fat. If you just reduce calories, you will lose weight. The problem, though, is I'm talking about what causes obesity, not how to treat obesity. So caloric restriction, once you're fat and you've gained all this weight, you've got to burn the fat off. You've got to learn, and GLP-1s work great that way. They reduce your food intake. They do all kinds of other things.
1 minute.
Okay, but losing weight requires caloric restriction. But I'm talking about what causes weight gain. And what causes weight gain is the stimulation of food intake. And here's a really cool thing. If you take a mouse and you feed it sugar, it will gain weight, and it will stimulate dopamine in the brain. But if you knock out its taste receptors, so it can't taste sweet, it will still seek sugar and it will still get fat from it. And so it turns out it's the metabolism of fructose that drives that weight gain. And we actually published a paper on that. Okay, I'm done.
Thanks, Rick. So what I'm hearing is that the energy balance model does not necessarily refute anything that you're saying,
Right.
but maybe Layne could maybe correct that or add some nuance to that. So, or what you
So
said.
Rick, sorry, Tom, I have a quick follow-up question. What was the fructose level in the animal studies that you were referring to?
Yeah. So you are getting to a very good point, which is that in mice and rats, you often have to give large amounts of fructose to drive obesity. But we actually figured out why that is. And fructose raises uric acid, but in mice and rats, they have an enzyme that keeps the uric acid levels from being high. And so if we inhibit that uric acid enzyme in the mice, then we can create metabolic syndrome with just 20% of fructose in the diet.
Okay. So I think the first thing I want to point out is a slight correction, and Rick, I think you'll be fine with it. You said when you do a keto diet, you don't have to restrict calories. I think you mean just like kind of counting or actively like restricting. Right. You still restrict calories because that's how weight loss occurs. So the keto diet doesn't cause it outside of that. Okay, just want to make sure.
Yeah.
Just for
just so you don't need to tell them you restrict calories because they just naturally will restrict calories. Yeah, sure. Absolutely right.
And you tend to see that with, when you move to diets that exclude a single macronutrient, it's very hard to consume hyper-palatable processed foods on a single macronutrient restricted diet. And that's the case even for if you go super low fat, high carb. That being said, a lot of people find the low carb a little bit more sustainable for them because it's a little more food options if you want to eat out, that sort of thing, versus like trying to do a really low fat diet. Right. Okay, so I think the first thing I want to point out here is I'm going to be very boring in going back to mechanisms versus outcomes here. So you're right, Rick. I have been talking about weight loss, but there's several different studies where it's not just weight loss or weight gain. It's kind of just looking at, regardless of whether or not it's overfeeding, underfeeding, if we isocalorically exchange fructose with other sugars, do we see a difference? And I've got a few randomized control trials as well as meta-analyses here. And of course, I've shared my studies with you guys. And Dom, if you want to make these notes available for the public, happy to do that. So when you exchange in a 1-to-1 ratio, you actually see very little impact on cardiometabolic markers. I mean, basically no significant impact. No change in insulin sensitivity, no effect on body weight. It doesn't induce non-alcoholic fatty liver disease in a meta-analysis when you're exchanging it 1-for-1 with other forms of sugar, and doesn't appear to affect blood lipids either, or even increase triglycerides when you're doing that. Now, Rick, I think I like what you're saying about these observations, and I think it's really interesting to look at, okay, what's happening with leptin, what's happening with overfeeding. I think that's great. And you and I agree that yes, like this is being driven, like overfeeding is being driven by appetite. But I think our interpretations of that are a little bit different. And I'm a pretty big fan of Occam's razor, which is when the lay interpretation for our listeners is when all things are equal, the simplest answer is usually true. The more scientific meaning is when all things are equal, the hypothesis requiring the least amount of assumptions is typically true. And so when I would look at the data you're presenting, I would say, okay, these animals are consuming a solution high in fructose, sugary. It's not going to be satiating. And so it doesn't surprise me that they gain weight because they're going to continue their normal food intake. And then we see this in humans too. They start consuming soda. You drink a soda in a day. It's not like you go, whoa, man, really full from that soda. I guess I'm not going to have that pasta tonight. Like that doesn't really happen, right? Like those aren't very satiating things. And I can tell you that, when I do a lot of posts about diet soda and how it's not the great evil it's been made out to be. And on every post, I'll have somebody say, all I did was cut out sugar-sweetened beverages and I lost 50 pounds or I lost 100 pounds. I mean, it really is a major driver of energy. And so my interpretation is, Rick is right. Fructose does not stimulate leptin. because leptin is stimulated through the hexosamine pathway, which basically it's glucose and insulin that drive leptin production. And in fact, you will see leptin and insulin basically mirror each other. So as insulin goes up, leptin goes up. As insulin goes down, leptin goes down. As insulin sensitivity goes up, leptin sensitivity goes up. And they kind of follow each other. And that is part of that pathway. Fructose does not stimulate that pathway. And so, what we would expect to see based on that, and again, mechanisms, right? We'd expect to see increased energy intake, all things being equal. And yet I have here that randomized control trial I was discussing where they fed people 150 grams of pure fructose per day, and they actually saw them drop their energy intake a little bit. And they didn't see any negative outcomes from this, other than they had some gastrointestinal issues because if you eat a lot of fructose, a lot of people have some sensitivity to fructans. They can ferment them. It can cause gastrointestinal discomfort. So some people reported that, but that was really the only negative side effect. And again, this is one of those things where how can this study exist if this is true? Because this, I know, Rick, you said that it takes a couple of weeks for you to start seeing these effects. Well, this was an 8-week study. I mean, we'd expect to start to see these effects after, a few weeks, and we don't. And there's some other studies where a little bit shorter term in nature, but they even found that fructose preloads before meals decreased energy intake more than glucose preloads and actually decreased energy intake to the same extent as milk. And, there's also another study where they looked at different graded levels of sucrose or high fructose corn syrup and eating the same amount of calories. And again, Rick, weight loss. So, to your point, that is a limitation of this study. But they found that all the groups lost the same amount of weight, even with double the amount of fructose in some of those groups. And so I think it kind of gets down again to, I just am going with I am not refuting anything that Rick said in terms of the data that they observed. I'm simply saying that I interpret that a little bit differently. I think the simplest answer is, well, sugary sources or liquid sources of calories are not satiating. They don't decrease that energy intake. And so if those animals continue to consume their normal diet on top of that, then they will become obese. And obesity drives insulin resistance, drives leptin resistance. It is really interesting, how this occurs, and we could get into the teleological aspects of obesity. But, fat cells, tell people they're more or less like little sponges, right? Like if you, I'm making a very poor reference here, and I'm sure like physiologists are going to cringe at it. But as you pump more free fatty acids and glucose in, those fat cells expand and they secrete more leptin and more, they don't secrete insulin, pancreas secretes insulin. And a funny thing happens, the more leptin you put into the system, the less sensitive your body becomes to it, right? And as they shrink, leptin sensitivity goes up, but leptin levels drop and things start to normalize. So I just think that we're probably arguing a little bit more. Is it the cart? Is it the horse? Is it the chicken? Is it the egg? Right? And at the end of the day, I do want to point out that my recommendations, if people want to lose weight or not become obese, are and include: do not drink sugary drinks, do not eat a diet high in hyperpalatable foods. And part of that probably is going to mean avoiding fructose. But if we look at, again, whole food sources of fructose, the fructose molecule is not different than the fructose molecule that we find sucrose, it's bonded, but that's going to be broken up during digestion. And it's not different than free fructose. And so even in diets high in fruit, we see people who eat more fruit tend to have less body weight. And I know, Rick, there was a study that you did where I think they gave a low fructose diet.
Yeah.
And then they gave not a high fructose diet, but I think it was 70 grams of fructose in a day but mostly from whole food sources, which 70 grams is right around the average like American consumption of fructose. And actually, the higher fructose group lost more body weight. Now, again, I find it difficult to reconcile that with the current hypothesis. Now, the confounding variable, the moderating variable, is that fruit is satiating because it contains fiber. So it's a confounding variable. But again, I go back to, I still think the simplest explanation here is probably true, which is when giving fructose as part of some sort of solution or drink or as part of hyperpalatable foods, that people tend to overeat and not compensate their energy expenditure elsewhere. And just one more point to show the impact of hyperpalatability on energy intake. Kevin Hall did a great study at the NIH where they took people, crossed them over from a minimally processed diet to an ultra processed, highly palatable diet, or vice versa. And overnight, the difference in calories was about 500 calories a day. Right. So just spontaneously, they didn't tell people, they didn't really give them many instructions at all, other than, hey, eat till you feel satisfied. And so just that spontaneous change, or just that change in diet, spontaneously caused them to increase their calorie intake by 500 calories a day. So yeah, I'm a little bit more, I acknowledge all that data, but I think the simplest answer is probably true.
So just to clarify, nothing Rick said is really refuting the energy balance model and kind of
No, I
is
think
its
Rick actually
own
is
sort
saying
of
he supports
hypothesis.
them. I'm sorry,
Yep,
Dom.
yep.
I
No, no.
got you off. No, I think Rick is saying he actually supports the energy balance model. I think, and Rick, please correct me if I'm wrong. I think what he's saying is what's driving the change in energy balance is the consumption of fructose. But we're probably disagreeing about the mechanism, I guess, driving that change, right? I'm saying, hey, these things aren't satiating, and so people just aren't compensating for it in the other part of their diet. I think Rick's going a little bit more granular and saying it's going to increase uric acid, which is then going to lower ATP, and that's going to cause people to overeat. And again, there are 3 studies here I have linked in my notes that long-term high fructose intake doesn't increase uric acid in humans. And these were studies anywhere from 12 weeks to 1 year at 50 to 60 grams of fructose added to the diet per day. And so probably higher than what you typically see in the American diet. And I know they've also done some short-term studies, I think upwards of almost 200 grams of fructose at one sitting, and didn't see an increase in uric acid production in humans. And again, I'm not wanting to dog animal studies because all my PhD sitting right back there was all in rats. So I'll be the last person to dog it, right? But I think, sometimes we can see interesting things in animals because we can put them under constraints that we can't put humans under. And so I just go back to like, what is the effect in kind of the overall outcome in humans in like a normal kind of diet?
Hey, Rick, I want to just a question, just, because we're talking about animals and maybe the relevance, are the animal studies flawed? Are they relevant? But also the hunter-gatherers. And it just a question that a couple people had with comments on the social post is like, how much fructose did the average hunter-gatherer, of course, is geographically, uh, contingent, but
Before
like,
you answer that, Rick, sorry, I want to say one more thing because I really want to emphasize that I don't think animal studies are bad studies. Okay. So I have a Venn diagram in my research review where I discuss like different types of studies. So if you want like highly controlled, long duration, going to be very low subject number in humans. If you want long duration, high subject number, very low control. If you want high subject number, high control, very low number of people and very short in duration. If you want all those things, then it has to be in rodents. You don't really have another option, right? So if you want highly controlled, high subject number for a long period of time, it's going to have to be in rodents. So there is where the advantage to animal studies comes in. But again, we have to show that we can robustly produce those in humans as well.
yeah, that was a good summary. Yeah, so animal studies are informative, but not always predictive. So I think we could say that too. Essential fatty acids are crucial for brain function, hormone production, immune response regulation, skin health, and proper cardiovascular function. C15 is the first essential fatty acid to be discovered in over 90 years. Low C15 levels can wreak havoc with your metabolic health. Higher levels are associated with many health benefits that we've actually discussed on a previous podcast. And what's interesting, without even realizing it, that most of us are deficient in C15, which can significantly decrease our energy levels and our metabolic resilience. Fatty 15 is a science-backed, award-winning, pure C15 supplement. If you are trending towards more plant-based, if you're vegan, if you're vegetarian, you are most likely deficient in this essential fatty acid. I personally found that my C15 levels are within a good normal range, although my diet's very rich in foods that have C15. Not surprisingly, others have told me that they now supplement C15 due to their tests showing a clear deficiency. So you can get an additional 15% off their 90-day subscription starter kit by going to fatty15.com/metabolic link and using the code metabolic link at checkout. Now back to our episode.
Okay, so I'm going to get to the hunter-gatherer thing, but first I just want to thank Layne for his comments. And, what we're talking about is what's driving obesity, and we're also talking about how to lose weight. And there's slightly different stories. But when we talk about what causes weight gain, we both are in agreement that the weight gain is driven by an increase in calories. When you inject fructose into the brain of a mouse, it will immediately become hungry and increase its food intake, and its ATP levels go down in the brain. If you inject the brain with glucose, ATP levels go up, and the animal does not search for food. In fact, will not eat. It's satisfying. So there's a big difference between these two sugars. The way that we were able to prove that fructose was important was because we developed a mouse that could not metabolize fructose. So this mouse can't metabolize fructose. And it was through that mouse that we found that we could block the effects of sugar, and we could even block a lot of the effects of different diets. And what we discovered was that it isn't just the fructose you eat, it's the fructose you make. Now, it turns out that the foods that stimulate appetite, like the sweet taste, encourages foods that contain sugar and fructose. And when you block the sweet taste, the animals will still seek sugar and will still become fat. And so it's a very interesting thing that it's like the sweet taste was there to help encourage you find those foods, but actually it's the sugars driving the fructose metabolism is what's driving the food intake. Interestingly, salt activates the enzyme that converts glucose to fructose. And so salty foods, when you give them for a long time, actually also induce obesity. And what we found is that when we blocked fructose metabolism, we could block the effects of salt to increase obesity and blood pressure and so forth. And in fact, the reason French fries are so bad is because not only do they contain a lot of carbs and fat, but they're also salty. So they all encourage this. Interestingly, when an animal becomes leptin resistant, they start seeking fatty foods. So there's an association of sugar and fat that also occurs, because if you make an impair leptin signaling, then they actually will start to be more attracted to fat. And even umami foods, we've shown that actually activates into this pathway as well. So what we think is that hyperpalatability, the foods that we love to eat, that, like what Kevin Hall did, are actually foods that either generate fructose or contain fructose. And in fact, in that hyperpalatability study where he controlled for protein and fat and carbs, he did not control for salt. And we know that the high salt will immediately increase fructose production in the body. The problem with our studies is that we have a mouse that can't metabolize fructose. So we can show that there's a role for fructose from carbs and so forth, but we can't really prove it in people that it's the fructose that's driving it. And until there's a fructose inhibitor, we won't be able to prove our pathway. But I will tell you that the keto diet is a carb restriction, and the only way you can make fructose is from glucose. So when you're on a keto diet, you really are not going to be able to make much fructose, even if you're eating salt, and even if when you go on a keto diet, the people, as you know, Jeff Volek and the people at Verta have shown that it can have dramatic effects on type 2 diabetes, on improving triglycerides, on slowing kidney disease, and so forth. And there's a lot of excitement about keto diets for this reason. I should also say that I did a study where I gave 200 grams of fructose for 2 weeks to individuals in Menorca, and 25% of them developed metabolic syndrome in that first 2 weeks. And that's like a world record. So I'll just say that, large doses of fructose, some of them cause GI upset and so forth, as you say, and it's not particularly relevant clinically. But usually to get metabolic syndrome, it takes years and years, not 2 weeks. And I can send you that paper. But the meta-analyses that you talked about are mostly caloric restriction or controlled feeding trials. And when you do a controlled feeding trial and you're calorically restricting, you're taking out a lot of the way the fructose works. And in fact, if you restrict calories severely, if you go down to like 50% where you're almost like catabolic, the fructose will not store fat. The fructose will be converted to glucose and turned into energy. So if you're on a severe caloric restriction, sugar is actually just going to be used as a calorie to help prevent for protein sparing and so forth. And that was shown by a guy named Sherwin at Yale, where he took obese people and he put them on a severe diet restriction, caloric restriction, and then gave small amounts of fructose. And the fructose was used fructose lowered uric acid in those studies, and because it was blocking protein catabolism. So in severe energy restricted diets, probably sugar is not going to have these big metabolic effects. Sugar is really meant to have a metabolic effect when there's a lot of food around, because the body, the body wants to protect itself. One of the incredible things too is this issue. You mentioned the uric acid studies. That's a trick. Those studies were tricks. What they did was they gave sugar and then they did a fasting uric acid the next morning and showed that it didn't go up. All the studies that look at fructose causes an immediate rise in uric acid between 15 minutes and 2 hours. So like the studies by Cox et al. And so forth that looked at postprandial or after a meal, if you eat sugar, your uric acid goes up at 30 minutes. But if you wait till 24 hours, the uric acids come down by then, right? So it's just like eating a cupcake, your blood sugar is going to go up, but the next morning it's going to be back to normal. That doesn't mean that cupcakes are good and don't raise blood glucose. It's just that it relates to the timing of the blood draw. And that's a trick. Anyway, the main thing I guess I want to say is that we have two main things. One is, you're overweight. What's making you overweight? And it turns out that we believe that fructose is the driver. Interestingly, the longer you become obese, what happens is the fructose is like causing oxidative stress to those mitochondria. And over time, the mitochondria will fission and then reduce in number. So once the mitochondria are low, it's very hard you can diet and lose weight, but it's going to want to go back up because your energy production is so low. And so there's a lot, calories will be stored more easily. But if you've only been obese for a short while and you do caloric restriction, you can often keep the weight off longer because your energy is better, your mitochondria are healthier. And things like exercise and things that you and Dom and Layne that you do help maintain and let those mitochondria grow. And so that it's a really wonderful thing to couple exercise as a way to kind of stimulate mitochondrial growth with weight loss. And so the bottom line is, if you lose weight and you continue to eat sugar, it's the energy, the weight regain is going to be very significant. And if you go on a keto diet, it's been shown, like with Ozempic, if you stop Ozempic, weight goes back up. But if you stop Ozempic and you're on a keto diet, you can help keep that weight down. But I think that there's two mechanisms. One is that sugar is driving weight gain, and then over time you start losing mitochondria, and that compounds it. So it's a complicated topic, but basically there's weight loss and weight gain, and the weight gain seems to be driven a lot by sugar.
So in the context, just for the audience here, what I'm hearing is in the context of energy balance, in the context of a calorie deficit, you could have a high fructose, high sugar diet and not necessarily suffer the consequences. In the context of a caloric surplus, that fructose could be a major contributing driver to weight gain, especially when compared to other forms of carbohydrates and, of course, other, excess protein calories. So are we in agreement there?
Yes. If you're in caloric excess, sugar is going to drive weight gain. So if you're in severe caloric restriction, the sugar is going to be converted to regular calories to kind of help control the catabolism. So it's if you go like 10% reduction in diet, the sugar is still going to be acting to drive weight gain. It's when it's like under maybe 1,100 calorie or less. There's the evidence would suggest that the sugar is not going to be as dangerous in that setting.
Okay. But so going back to Layne, do we have human controlled randomized studies that support that? Or it sounds like no, from what you said, maybe the opposite.
Well, actually we do.
Okay.
The study that Layne showed by Stephen Piper showed that in controlled feeding trials where it's isocaloric, he doesn't really show a weight gain from fructose. But in situations where fructose given and there's caloric excess, fructose is associated with dramatic weight gain. The issue is, Layne would say it's the caloric excess that's driving the weight. And I would say that it's the fructose driving the caloric excess.
Right. And so those sorts of things are difficult to disentangle.
Right.
And I think where I would go to is some of these, first off, it's difficult to get overfeeding studies. Firstly, because of IRB approval, because if you overfeed people, guess what happens? They get less healthy. And some IRBs are very sticky about that. And so it's difficult to get those over long periods of time. This meta-analysis I have here did show in hypercaloric trials, the conclusion was that the increase in weight was due to the caloric content and not the fructose necessarily. Now, I want to go back and get a little bit more granular with Dr. Johnson here, because I think part of this is, like I said, if a hypothesis I believe is really robust, it should stand up across various different levels of measurement. Now, I think it's interesting to bring up sodium and salt, because that actually can help reduce some of these confounding variables that are present in some of these feeding studies. So if we have studies where we reduce salt, which is going to reduce the conversion to fructose, that should help account for the fact that some fructose is endogenously produced. I'm looking at a human randomized control trial here, where a low salt diet, which was a half or a third of the control diet salt intake or sodium intake, did not have an impact on body fat. It had an impact on body weight, but due to body water. So they measured body water, total volume, body fat. They saw a difference in weight, but it was due to a reduction in total body water. There was no change in levels of body fat. And as far as
how long was the diet?
good question, Rick. Let me see here. One moment, because I actually was looking this up as you were mentioning it. So let me just look here, because it's actually not in the abstract, which is abnormal. So it was 2 months.
Yeah. In our just to let you know, in our studies, the effects of salt to increase obesity in mice, for example, took like 6 months. And in the first 2 or 3 months, there wasn't much effect. So it's a long-term effect with salt. It's much faster with well, sugar is still pretty slow, but it's twice as fast as the salt.
So my argument would be probably that the hypothesis isn't that robust then if it can't be shown. Now, the other thing I want to point out is there are a couple of studies looking at uric acid with high levels of fructose intake, and I have to go back and find them. I know they exist for sure, but like up to 150, I think in one trial, 200 grams of fructose at a time. And they did see an increase in uric acid, but not compared to other sources of carbohydrate. So I guess you could argue that perhaps, okay, if you're giving glucose, that's being converted to fructose, and that's what's driving this. But I think, again, this stuff is difficult to disentangle from just overall energy intake, right?
One of the, I'm sorry, I'm interrupting you.
That's okay, go ahead.
Okay. When again, it's in animal studies, but if we give glucose to mice, the glucose is converted to fructose in the liver, but it's not like when you take a soft drink, you get this big wave of fructose, so the uric acid spills out from the cell into the blood. But when you give glucose and it's being converted to fructose, it's kind of a different kind of shape. It's more of a lower plateau. And what happens is we found an increase of uric acid in the liver, but not in the blood. And the same thing we found with salt. If we gave salt to animals, the uric acid goes up in the liver, but it's not enough to spill over into the blood. So the serum uric acid is a marker, but not really the driver. It's the intracellular uric acid that's driving this, and they can be dissociated. That's one of the problems with this. But I agree that in experimental models we can show this very well, and it's hard to show it in humans because we don't have a way to block fructose metabolism yet. So I think when the real proof will come when the fructose inhibitors are introduced into, as a treatment. And if the fructose hypothesis is correct, those fructose inhibitors will have a very profound benefit, especially for preventing obesity and diabetes, more so than treating, because as we mentioned, to treat obesity, we really have to burn the fat off and go on a caloric restriction to get rid of the fat.
Now, Rick, when you say a fructose inhibitor, and now I'm interrupting, so I apologize.
Yeah, no,
when you say a fructose inhibitor, do you mean something that inhibits the conversion of glucose to fructose, or inhibits the absorption of fructose?
Well, there's three types of inhibitors that are being developed. One is to block the conversion of glucose to fructose. Those would be like an aldose reductase inhibitor. There's some people working on that. There was an aldose reductase inhibitor that was introduced in the 80s, but it had all these side effects, and so that were probably unrelated to the enzyme. And so it was stopped. Then there's also inhibitors that block the metabolism of fructose. And those are the ones that I've been involved in. We've been trying to make inhibitors, but Pfizer and Lilly and other companies have also tried to make fructokinase inhibitors. It's been challenging. Pfizer actually had one that they took to market, but they did stop it at phase 2. And the argument was that they were seeing a reduction in fatty liver and an improvement in insulin resistance, but it was less than they were hoping for compared to some of the other things they were looking at. And the question is, why was that? But, what we're looking at is blocking. We find that fructose drives fatty liver. And so it should block the development of fatty liver. If you have fatty liver, I'm not sure it's going to make it go away very fast. It may help prevent it from getting worse. Do you see what I'm saying? So anyway, I think we need, this is the area that we need more evidence for. We need to get, an inhibitor that we can really test for its potential benefit.
Rick, quick question because you're familiar with this topic. So could you develop a GLUT5 inhibitor or use something like allulose, which is an epimer of fructose? And I mean, but allulose doesn't have the same amount of, it's not calorically equal. So
Right.
What about those two ideas?
If you block GLUT5, the fructose can't be absorbed, so it ends up in the distal part of the gut and like in the cecum and the large bowel, and it can be fermented that would cause a lot of side effects. So GLUT5 inhibitors probably are not going to be useful, even though they block the uptake of fructose. They would block the effects of fructose, but would be associated with lots of side effects. Allulose is a really kind of cool sugar, as you and I know. It's a natural sugar that looks like fructose, but it does not get metabolized like fructose. So it looks quite beneficial in many situations. It becomes a candidate for replacing fructose. And, you and I have allulose is now available in the US. There are chocolates and stuff that are made of allulose. Uric Sugar is a company that has some of this, and you and I have been advisors to that group. And, it does look promising. More studies need to be done, but basically it does have some real benefits, it looks like.
So is that the potential, solving the sugar problem with allulose, or coming up with something that has, similar sweetness, but does not, decreases our fructose and overall sugar consumption? Because especially in sugar-sweetened beverages, since 49 to 63% of the population consume at least one sugar-sweetened beverage per day, and that's 35 to 37.5 grams of sugar per liquid bolus, which is hitting the liver. Like, I didn't realize it was that high until I just pulled the facts and
Wow.
So that's, 50% of the population is consuming a sugar sweetened beverage per day. So that seems like the low hanging fruit. And I think we all agree on that.
I like allulose.
Okay. So I guess,
do you mind if
we should probably start wrapping it up and have some
I'll wrap it up.
Okay.
I'll wrap up. I just want to respond to a couple things. So I think, again, one, some of this stuff is tough because, like Rick said, if you're going to measure intracellular levels of ATP in humans, you got to take a biopsy, which is very invasive, and people typically don't like that. It's hard to get through IRBs. It's hard to get a lot of subject numbers. It's difficult. I know this from muscle protein synthesis research. There's a reason it's easier to do in rats. It's because you don't have to take a gauge needle and go and take out chunks of flesh,
Right.
So yes, I absolutely, it could be that there's something different going on between serum uric acid or plasma uric acid versus intracellular. Obviously we don't have that data, and we're just speculating. Again, I would say that it is difficult to disentangle the effects of fructose from the energy and the effect of obesity, because excess adipose tissue has been shown to increase uric acid production. So I think my explanation is still, the simple explanation can still be true as well, which is, okay, there's this delay. It takes time for it to happen. Okay, well, it takes time for people to gain excess body fat. and then uric acid is going to go up. And I think there's even some evidence that uric acid is secreted from adipose tissue. So excess adipose tissue, people with obesity are going to have higher levels of uric acid. And again, I think it is still explained by the fact that, okay, fructose as part of a sugar-sweetened beverage, as part of hyperpalatable foods, as part of just a drink that you're consuming is simply not compensated for in another area by reducing intake somewhere else. And so overall effect is you start consuming more calories. There is an increase in body weight that decreases leptin sensitivity, decreases leptin sensitivity, decreases insulin sensitivity, and will increase uric acid production over time. So I think that's where this gets very sticky, and hopefully, like Rick said, we're going to get some more of these studies that are really going to like get more granular with it and be able to show us, with the fructose inhibitors, hopefully maybe we can start measuring some intracellular ATP, with isocaloric exchange in overfeeding studies of these things, because I think that would really kind of like, that's really what we need is a human randomized control trial where they're looking at intracellular ATP. They're giving either, high fructose versus glucose or another sugar or fat or whatever that's energy equated. And if we see a unique effect on that intracellular ATP, then I think I might have to think more about whether or not I'm changing my mind on this. But as of now, we don't have that. And when we do know that, I think it's important to point out that, again, I'm a fan of animal research, but if you knock out genes, if you overfeed things in really high amounts, and animals aren't eating mixed diets, they're eating the same, typically the same thing over and over and over. You can have a proof of concept, but less than 50% of animal trials translate into human outcomes. And so I think that's where the disconnect is here. And the reality is, I think Rick and I, if somebody sat down with us and said, what should I do to prevent becoming too fat? Or what should I do to lose fat? We would have very similar advice, which is control your calorie intake. Don't eat a lot of ultra-processed, hyper-palatable foods. Definitely limit your intake of sugary beverages. Absolutely, whether it's fruit juice or soda, whatever it is. And exercise and, eat fiber and protein. I don't think we're going to be any different on that. So I want to point out that I think our disagreements here are really in the margins, and kind of like what scientists like to do is to dig into the minutia and really figure out okay, where exactly, how is the train exactly put together? What order are those carts in, right? And I just want to point out that I think our advice is probably going to be pretty similar in terms of the end of it.
Mm-hmm. Yeah. Closing thoughts, Rick?
Well, I agree with this. Layne, you're right. When we talk about what's driving obesity, you're saying hyperpalatable foods are a key issue, and that leads to increased food intake and weight gain. And I'm basically saying the same thing, because hyperpalatable foods either contain or make fructose. So I'm actually in agreement. I do believe that fructose is also driving metabolic syndrome and insulin resistance and so forth, even without the excess calorie intake. And I think that is where we slightly differ. I also think that when it comes to weight loss, it's absolutely true. Any caloric restriction will work, but I do believe that reducing carbs and reducing fructose by reducing carbs will tend to be a little bit better in terms of its effects on the metabolic syndrome. So not necessarily on weight, but on features like diabetes and so forth. And I think there's beautiful studies by Verda with the keto diet showing these benefits is true. If you're on a dramatically severe caloric restriction, like to the point where you're catabolic, and then the fructose, if you eat any, will actually be used to help block. It will act like a calorie to help block the breakdown of protein. But most people, when they diet, they're not doing this kind of severe diet. They're doing like reducing calories by 20 or 30%. And there I do think a low carb, low sugar diet is probably superior. So we have two things. We know what's causing obesity and how to treat obesity. And the other thing that I try to point out is that it isn't, the fructose tends to cause oxidative stress to those mitochondria, which are our energy factories. So chronically eating a lot of sugar and ultra-processed foods can knock those mitochondria down. And so that may be one of the reasons people have trouble regaining weight. Keeping their weight off, when they diet and exercise and doing things to try to help those mitochondria may be very beneficial. And being on a low sugar diet will help you to help recover those mitochondria. So basically, I agree with Layne in many, many things. I knew I would from the very beginning. His book, Fat Loss Forever, really talks about energy balance as a key aspect to weight loss, and I do agree with that. But I do believe that there's a mechanism driving weight gain that we've really focused on today, which is sugar, and that should be part of the equation. And it sounds like he feels the same.
Well,
Yeah,
thank
like
you
I said,
both.
it's a disagreement over the kind of the sequence of events, I suppose. And
Right.
I guess I would say that I'm taking a little bit more of the simpler approach until the research may show otherwise. I personally don't think it will, but I look forward to the research studies because I think, every time we do this, even if I'm wrong, I'm happy to find out that I'm wrong because I always tell people being wrong is a beautiful thing because if you're right about everything, then you're already maxed out. You can't improve anything. I will
Exactly.
say I'm sorry to throw one in at the end, but in studies looking at fructose versus other sugars exchange one to one, they don't really see an effect on insulin sensitivity. So again, I think in the human trial,
Is that the Anderson study?
let me just pull it up here real quick.
Is that the diabetes study?
No, this is a study with Evan. So this is actually a systematic review and meta-analysis. Now I want to point out they were looking at fasting glucose, insulin, triglycerides, which fasting insulin in terms of insulin sensitivity. But typically, if you have poor, decreases or poor insulin sensitivity, you will see increases in fasting insulin, glucose, and triglycerides. So this is a little bit of a proxy, but a meta-analysis on that one.
Yeah, send it to me because a lot of times they say we substitute fructose for other sugars and they'll like substitute it for sucrose, which actually contains fructose. Or so we have to be a little careful about that.
Yeah, and so they did substitute fructose for either glucose or sucrose. So at least
So sucrose, that's kind of cheating because sucrose has fructose and glucose, at high doses, we know for a fact it's converted to fructose. Even in humans, there are now studies showing this. So we have to be careful. All right. Well, thank you very much.
Yeah, thank you both for sharing your expertise, and your opinions on this topic. I think, Rick, the science is very compelling that you shared, and I think maybe our current human studies do not capture and test that particular hypothesis, and we need better studies sort of to test that. But sort of, there's evidence out there, but not a well-designed study to test in humans, at least. But also with the understanding that mammalian physiology is conserved. So, animal studies are extremely informative, and we do animal studies in our lab, but not always 100%, predictive or translatable. So
I'll just leave you with the story of the hummingbird. The hummingbird drinks nectar, which is basically sugar water, and it becomes diabetic every day. It gets the fattest liver of all birds, pearly white liver, they call it. The blood sugar goes up to like 500, but because they have incredible metabolism, they'll burn off during the night. They'll burn off the fat, and their blood sugars will return towards normal during the night, and then the next day they go out and do it again.
Yeah, so it's a beneficial feature of their physiology, and I think There are a lot of
Yeah.
humans walking around that are sedentary, that are not so active, right? But I think everybody, we can all agree that, as we wrap it up, that too many people are drinking sugar sweetened beverages, about 50% according to
Yeah.
statistics. So I think we
Right.
universally agree that that's needs to cut back. And
Yes, and I just want to add one thing. It's so drinking sugar sweetened beverages is probably the equivalent in terms of like ease of improving your health nutritionally would be equivalent to like the effect of quitting smoking on cardiovascular disease. It is literally the hack. It is the one thing that you can do that will very, very, very much make a massive difference. Now, we might disagree about why the difference is made, but we don't disagree that if you could do one thing, if you're obese, overweight, or you want to prevent getting there, if you consume sugar sweetened beverages, if you cut them out, it will make a big difference.
what if you
Bravo.
were Pop-Tarts? Not sugar-free.
I don't know how I got the moniker as the Pop-Tart guy. I don't even like Pop-Tarts now.
Okay. But there's something unique about sugar sweetened beverages. So that's what you're saying. It hits the liver like a bolus and just, relative.
I think the unique part is that it's hyper palatable and very low satiety. It doesn't have an effect on satiety. You can drink 5 sodas and still eat 3,000 calories in a day and be like, okay. And if you cut those 5 sodas out, you'd probably have the same level of satiety eating 3,000 calories or similar. And so again, I just think it's a very, very eeasy way to get a lot of unnecessary calories out of your diet.
Yep. And that probably all falls back on the mechanisms Rick was talking about too, to some extent. So
Exactly.
that's debated until now. Yeah. Till future. So, well, thank you both for, taking time out of your day to be here. I think this is the most nuanced discussion on this topic that exists, and I'm excited to share it on the Metabolic Link podcast, and we'll get this posted pretty soon. So thank you again, Dr. Rick Johnson, Dr. Layne Norton. This was an amazing discussion, very civil, very balanced, and it's given a lot of insight into this topic, and appreciate your time and expertise and thoughts on this.
Well, next time Rick and I can have our WWE main event, in a steel cage match. So
there you go. Yeah, exactly. Or we can do it over a chess game. Maybe I might have a better chance to win that way.
Oh, you'd have all the chances to win that one. I still to this day, I don't think I've won a chess game against my father. So yeah, I think that you would absolutely have me there. Thanks, Rick. I enjoyed it.
All right. Thanks a lot, guys.
Great. Thank you, guys.
Bye.
Thanks, Dom.
Take care. Yep. Bye-bye.
Thank you for listening to this episode of the Metabolic Link. If you've enjoyed it and would like to see more debates like this, please let us know. We're glad to include them. Please leave a review, a comment, or share this episode with a friend. If you'd like to listen to more ad-free episodes of this podcast, please head over to our medical education platform. So that's the Metabolic Initiative. So there you'll find hundreds of different videos from world experts on metabolic health and therapy, new presentations, and live Q&As from thought leaders across the globe. Visit membership.metabolicinitiative.com to learn more. Thank you again for watching and listening to this episode.